Crash helmet design, prototyping, and testing. The test phase. Hi, I'm Camille McHugh. You've now gone all the way through the design thinking process and you've reached the test phase. In this video, we'll take a look at how we got here as well as what happens during the test phase. Let's get started. So as we enter the test phase, I would like for you to consider these final thoughts, and they relate to helmet tests, concussions, and the actual egg drop process. The first video is a student-made video that includes some slow motion egg drops. Very well done. It really allows you to see in slow motion what is happening as that egg or the egg in its helmet hits the hard surface. The next two videos explore how helmets work and how they're lab tested. And then finally, please take a look at this TED Talk from Stanford that explores how mouth guard sensors are used to measure and model how the brain moves during a head impact. It's excellent. And keep in mind that we've moved throughout this design thinking process by focusing and flaring at each phase as we move along the way. Now, as we're entering this very tail end of the test phase, we're focusing, we're testing out our final prototype, and we're aiming to come up with a finished product that ultimately, once fully tested, we could take to market. Remember, we started with empathizing to try to understand the problem of traumatic brain injury, and our goal was to seek to understand and to be non-judgmental in the process, just to research, ask questions, and get to understand the problem. And then we worked in the define phase, and your design team wrote a problem statement. That problem statement informs how you made your prototype and ultimately how we determine whether or not our test results demonstrate that we met our specifications. For mine, I wanted to ensure that I could have easy ingress and egress, 5 seconds apiece, that the helmet did not interfere with any user mobility or sensory functions, and also that it would survive an altitude of at least 2 meters. More would be great. During ideation, we came up with a variety of ways to address our problem statement that we developed. The ways that we can avoid head injuries are to look at the solution from a system-centric, a device-centric, and a user-centric perspective. If you made a giant container that just completely goes around the egg, that is a device-centric solution, and it very likely does not allow the egg to retain its sensory functions or its mobility. So that was not the goal of what we wanted to achieve. We wanted to be able to develop a user-centric device and place that on the participant, in this case, the egg. And when we prototyped the egg helmet, we wanted to ensure that we did so addressing all of the design specifications that we laid out in the problem statement. We were able to use the 3D design programs and the 3D printers to make a quick mock-up, adding some additional padding and any additional drag features. Remember, the goal of the prototype phase was to make some simple mock-ups, to iterate quickly, and to fail fast. And we actually would move back and forth between the prototype and the test phase, depending on how we do in the test. Now, in the test phase, you need to drop that egg. So first measure the time it takes to put the egg in the helmet, because remember, that's part of your problem statement. If it takes 30 seconds, that's probably not going to be a helmet that's going to be put into practical use. Use the same type of egg you did previously when you made all your initial measurements, and position the egg however you desire, whether it's helmet down or base down. That's entirely up to you, but make sure that you do what you did before when you made your test without the helmet. Your drop distance is the distance from the tip to the floor, and you're going to drop it onto a hard surface. So step 1, drop the egg in its helmet from rest onto a hard surface. I want you to start at 200 millimeters. That was about the maximum altitude that the eggs were able to sustain when they were not protected with a helmet. So drop from there, and if the egg is uncracked, add 100 millimeters and repeat, drop again. Keep dropping until the egg cracks, and at that point, record the altitude at the crack. If the helmet cracks, you can go ahead and test again, because if the egg remains intact, then it did its job. And finally, evaluate your results. How did the helmet do? Consider how you would continue developing, though, your helmet iteratively. And what does that mean? That means repeating the process, learning from your failures, adapting and adjusting, and adding new improvements. Remember, most major engineering design products inherently require physics and likely had some failures along the way. Rockets crashed. Robots took a long time to move from mechanical-looking devices that had to be wired to the ceiling to autonomous and freestanding robots that can walk around and serve as people helpers today. Richard Branson says every success story is a tale of constant adaptation, revision, and change. He also says failure is a hurdle, not a dead end. I hope that your egg fared well during the test phase, and that it met all of the design specifications that you laid out in your problem statement. More importantly, I hope that you gained content knowledge, skill, and confidence in working through the design thinking process. In any engineering major that you might pursue in university or for your professional career, you'll see it again. Good luck.